than that. So now let's do this one. Okay, give that one a shot. It's not very straight. Okay, Katie, what'd you do first?
I multiplied 1 over x by x squared over x.
Mm-hmm, good. Because we want our LCD to be x to the third. And so we get x squared minus 2 over x to the third. And that can't be simplified, right? Because I can't factor the numerator, so there's nothing to cancel. Remember, this is in parentheses. Okay, so everybody feel good about those two problems? Okay, so today what we're talking about is simplifying complex rational expressions. Whoops. So we're going to simplify two minus 4 over x squared over 1 over x minus 2 over x to the third. Threes. That's a 3. So what we just did is like half the battle here. So like what I want to impress upon you is that this isn't any different than what we did on Friday, right? You guys just did these two problems, and that's the first step to simplifying this complex rational expression, is to just simplify the numerator and simplify the denominator. So that's what we already did, right? Do you guys see that these are just the same expressions? So we start by getting common denominators. So I'm just going to do this really quick because we just did them. And if you prefer to do like the entire numerator first and then the entire denominator, that's totally fine. But keep them in the numerator and denominator. So like you can do like top, 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 and then bottom, 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 bottom. But don't separate them into two separate problems, because then you have to put them back together. And as these get more complex, putting things back together after you take them apart gets a little harder. So this was 2x squared minus 4 over x squared. And we factored, and we had 2 times x squared minus 2 over x squared. So that's exactly what we just did. I just put it in the numerator of a fraction. And then same thing in the denominator. We're just doing the same exact subtraction problem that we just did. I'm just putting it in the denominator of a fraction. And then from this point, I just want to do division. So again, this is a problem we've already learned how to do, right? We can do division of fractions. Remember that fractions represent division. So we can write this as 2 times x squared minus 2 over x squared divided by x squared minus 2 over x to the third. And how do we do division? Yeah, we multiply by the reciprocal of the divisor. So we have 2 times x squared minus 2 over x squared. And then to change that to multiplication, we take the reciprocal. And remember, if there's addition or subtraction, that goes in parentheses. Oops, I'm sorry, that's a 3. And then remember, like we talked about the other day, like if you have monomial factors, so factors that don't have addition or subtraction, you can think of them as their prime factorization. So this is 2 times x squared minus 2, and then x to the third doesn't have any addition or subtraction, so we can think of it as x times x times x. And x squared doesn't have any addition or subtraction, so we can think of that as x times x. Remember, we don't actually do any multiplication. So now I can simplify. So we'll cancel x squared minus 2, cancel a couple x's, and we end up with 2x as our final answer. So although altogether this looks more complicated than what we've done so far, if you think of it in smaller pieces, just like we did here, right? You guys were fine doing each of these problems on their own. We just put those into the numerator and denominator of a fraction. So even when you're given this problem all at once, you want to think of it in smaller pieces. So think of, like, I'm doing addition or subtraction in the numerator. That's one problem. I'm doing addition, subtraction in the denominator. That's another problem. When you're done with both of those, then it's just a division problem. So try to think of it as like 3 separate smaller problems rather than like trying to look at the whole thing all at once. Because individually the pieces of this are all things we've done already. We're just kind of making it look uglier. So let's do a couple more. So let's simplify. We'll do 1 over x plus 1. Oh, sorry, that's not a, this is a 3. Minus 4. Trying to remember what I did last time. There we go. X plus, there it is. All divided by 1 over x plus 3 over x squared. Make that a minus. Okay, give that one a shot. So again, think of just the subtraction in the numerator, the subtraction in the denominator, and then a division problem.
X plus 3 over x squared.
Okay, so what is your denominator in the numerator?
Okay, so it's 3x plus 3.
So 3 times x plus 1. Remember, we don't distribute the denominators. We keep them factored. So 3 times x plus 1 is your LCD. Okay. So x over 3 times x plus 1 over x plus 1 minus 4 over x plus 1 times 3 over 3. So our LCD is 3 times x plus 1. And let's see, give myself more room here. Then we just write x times x plus 1 minus 12. And then we distribute in the numerator because there's that subtraction, which is, remember, our goal is for everything to be factored. This is already factored, and so we don't do anything with it. However, this is not factored because of that subtraction. So the only way I'm going to get it to be factored is to distribute and then factor the trinomial. So we have our denominator stays the same, and then our numerator is x squared plus x minus 12. And then we can factor that numerator because now we've expanded it enough to combine everything. So let's see, this is still 3 times x plus 1. And I think this factors, what does this factorize? X squared plus x minus 12 factors as?
X squared minus 3x plus 4x minus 12.
And then keep going. Your final factorization is what?
X plus 4, x minus 3.
Good. Perfect. So now we'll go back to the denominator. Peyton, what's my LCD? In the denominator. So in just this piece.
Is 2 squared. No, x squared.
X squared? Good. Yep, so we're going to multiply 1 over x just by x over x. And then 3 over x squared, we don't have to multiply by anything. So we get x minus 3 over x squared. Which I have to copy in a couple steps here because there's not anything to do with it from there. And we have addition, subtraction in the numerator, so we put that in parentheses. What's next? Nick, what's next?
So you'd want to change it, instead of being in a fraction form, you want it to be the first fraction divided by the second fraction.
Good.
Flip the second one, so it's multiplication.
Good. So we have x plus 4 times x minus 3 over 3 times x plus 1 divided by x minus 3 times x squared. And then, like Nick said, we're going to take the reciprocal of the divisor to write that as multiplication. So x plus 4 times x minus 3 over 3 times x plus 1 times x squared over x minus 3. And again, remember, we're not actually doing any multiplication. We're just smooshing these guys together. So we can think of this as just one big fraction. And the only thing that's going to cancel is that x minus 3, right? So we have x squared times x plus 4 over 3 times x plus 1. Is that what everybody got? Good. Okay, let's talk difference quotients. So this is a graph of y equals f of x. We don't really care what f of x is. This is just a general graph of some function. And I'm going to just pick an x value. I'm going to call it x. And then I want another x value, and I just want it to be like a little bit bigger. So we'll say the difference between them is h. So what's my second x value going to be if they differ by h? Very close, but I'm to the right of it. So I'm bigger. Yeah, so x plus h, right? If I start at x and I add h units, then this is going to have an x value of x plus h. And then remember that the y-coordinate of a point is just f evaluated for the x-coordinate. So this first point right here, what's the y-coordinate going to be? So it's the function. What's the name of the function? F, evaluated for the input, which is what? X. So what's our y coordinate? Yes, it's f of x. And so what's the y-coordinate of the second point?
X plus h.
Yep. It's our function evaluated for the x value, which is x plus h. So as ordered pairs, this first point has an x value of x and a y value of x, or f of x. The second point has an x value of x plus h and a y value of f of x plus h. So I want you guys to write down the average rate of change, so a formula for the average rate of change between those 2 points. This isn't new. This is the average rate of change is still the same as it was before. Okay, Brendan, what did you write?
F of h over h.
So go back one step. What did you write before that? Like, did you simplify something to get there? How'd you get f of h?
I was just looking for the rise, and the only difference between the first point and the second point was h.
So you did the difference in the y values.
Yeah.
So f of x plus h isn't the same as just x plus h. We don't know what f of x plus h is because we don't have a rule for f. You can't subtract inputs from, like, when they're, like, just like when we did, like, f of, like, 4 minus f of 1, like, we couldn't say that that was 3 or f of 3, right? It just depended on the function. So since we don't have a rule for our function, like we have no idea what f of x plus h or f of x is, and therefore we don't know what the difference is. So we just write it as subtraction. And then you said your denominator was h, which we get, if I can make a straight line, which we get by doing the difference in our x values, right? So x plus h minus x. Well, here we can subtract because we don't have that f, right? We're not saying we have to apply the function in order to do the subtraction. Here we're just subtracting inputs. So x minus x is 0. And so these guys will go away. So that's our average rate of change. Another way of saying that is it's the slope of what we call a secant line. This is what we call a secant line. A secant line is just a line through any 2 points on a function. So the slope of the secant line is the average rate of change. And this expression, this general expression, is what we call the difference quotient. And this is what the derivative is based off of. So when you get into calculus, the definition of the derivative, which is sort of the basis for all of calculus, is it's the limit of this as those 2 points get really, really close together. We don't have to get into that part of it today, but we are going to work on just evaluating and simplifying difference quotients so that you have the algebra of it down. So we are going to, given a specific function, we can evaluate the difference quotient just by figuring out what f of x plus h is, what f of x is, subtracting and dividing. So we're going to do, I should copy that. Let's see. So we will give you that formula on the test. You don't have to memorize it. So the questions will look something like, find f of x plus h minus f of x over h for f of x equals, let's do 5x minus 9. So we have a function. The rule is multiply your input by 5 and then subtract 9. And we want to find f of x plus h minus f of x over h. So this is just like finding the average rate of change before, right? We evaluate one of the outputs. We evaluate the other output. Remember, we use those brackets. So if I'm evaluating f of x plus h, what's my input? For this piece of it, what is the input? So remember, the input is what's in parentheses. So what's my input? So the input is what is in parentheses, which is what? If I give you this, what's the input? 2. Okay, so for f of x plus h, what's the input? X plus h. Good. The input is the thing in parentheses. So whatever is in the parentheses is your input. So my function says take 5, multiply it by the input, and subtract 9. So this right here is f of x plus h. It's my function with an input of x plus h plugged in. for the input. And now we want to subtract. What's f of x?
5x minus 9.
So that's my f of x. And then all of that is just over h. So we evaluate the function for x plus h, just like we did like 3 weeks ago. Evaluate the function for x, that's the easy part, right? Because it tells us what f of x is. And then subtract them. So I'm going to have to do some distributing so I can combine like terms. So we have 5x plus 5h and I don't need to keep brackets around that because there's nothing to distribute out here, right? So distributing that 5 gets rid of those inner parentheses, and then there's nothing to distribute in front of the bracket, so I can just drop them. Whereas here, I have to distribute that negative in order to get rid of those brackets. So minus 5x plus 9. And that's all over h. The nice thing about the difference quotient is it like always works out really, really nicely. So you know when you made a mistake. At this point, everything that doesn't contain an h should add to 0. Is that true? Does that happen? Yeah, so 5x minus 5x is 0, and negative 9 plus 9 is 0, and so the only thing left is a term that contains h. You might end up with more than one term, but all the terms that don't contain h at all should add to 0. And then we can simplify this. We have a common factor of h. So that's the other thing that always happens, is you're always able to cancel that h. So these start out somewhat messy, but they almost always, well, they always do. It just depends on if, we won't do square root ones, so we don't have to worry about them getting super messy, but they always turn out really nicely. Like you end up adding a whole bunch of stuff to 0, and then you get to cancel an h. And that's always the case with these. So let's do another one. So we're going to find our difference quotient for f of x equals, let's do like x, let's do 3x minus x squared. Okay, so we start out the same every single time. You always want to write that expression on the left side. You don't have to write it in every single step, but you have to write it in the first step. So we have f of x plus h minus f of x over h equals, so starting with f of x plus h, my input is x plus h. So my function says multiply 3 times your input, and then subtract your input squared. So this whole thing is my f of x plus h. I want a little longer here, so then minus, what's f of x?
3x minus x squared.
So that's my f of x. So we're evaluating our function twice, right, for 2 different inputs, and then subtracting just like we did before when we found average rate of change, right? We do something like f of 8 minus f of 4 over 8 minus 4. We're doing exactly the same thing here, except instead of an 8 and a 4, it's an x plus h and an x. And the difference in the denominator is always h, so that's kind of nice. We don't have to do any work there. So now there's a bit of simplifying to do here. Again, there's nothing in front of this set of brackets that tells me I have to keep that set of brackets, right? There's nothing to distribute there. So we really only have to worry about distributing inside. So we have 3x plus 3h. And then remember, x plus h squared is x plus h times x plus h. We can come over here and do it real quick. You will do this so many times that you'll just memorize what this is equal to. So x times x is x squared. X times h is xh. H times x is also xh. And h times h is h squared. So x squared plus 2xh plus h squared. And when I put that in, it needs to be in parentheses because there's this minus right here. I can't drop those parentheses until I've distributed that. So we have x squared plus 2xh plus h squared. And then to get rid of those square brackets, I have to distribute this negative here. So minus 3x plus x squared. All over h. And so the last thing I have to do before I can start combining like terms is just distribute that negative to get rid of that last set of parentheses. So we have 3x plus 3h minus x squared minus 2xh minus h squared minus 3x plus x squared. And even though you know that a bunch of this is going to add to 0, don't just start slashing stuff, because this is how you make sure that you didn't make a sign error. Is if something doesn't add to 0, then that you know should, then you want to go back and be like, okay, where did I mess up my signs? If you just start slashing things out because you know they should add to 0, then you're not going to catch any sign errors. So let's see if it works. We have 3x and minus 3x, so that adds to 0. 3h, no like terms with that. Negative x squared and positive x squared adds to 0. Did everything that doesn't contain an h go away? (3h) contains an h, right? And negative 2xh contains an h, and negative h squares contains an h. So everything that didn't contain an h is gone. So we have 3h minus 2xh minus h squared over h. At this point, there's a couple ways you can approach this. You can factor an h out of the top. I'll show it to you both ways. So remember that this is addition, subtraction. We put parentheses around it. So we can factor out an h. And then that h cancels. So we end up with 3 minus 2x plus h. The other way you can think of it is that division distributes like multiplication does. So you can think of this as like 3 separate terms if you want. So 3h over h minus 2xh over h minus h squared over h. Yes?
On the first one, you crossed off the h's after you distributed the h.
After I factored out the h?
Or yeah, factored.
Uh-huh.
Why did it make it plus h at the bottom?
Oh, I'm sorry. It didn't.
Okay.
Thank you.
Yeah.
There we go. And then you'll see, like, you get the same thing either way, right? So we can factor out the h, or we can split it up into three separate fractions, or however many terms you have, and these h's cancel. So whichever one of those seems more intuitive to you as far as simplifying that last step. Like I told you in our first example, that h is always going to cancel. So you can do it by factoring the h out and canceling it, or you can do it by dividing each term by h. What you don't want to do is, like in this step, be like, oh, those h's cancel, right? Because then you only divided one term by h. And you have to divide all the terms by h. So that's what factoring it out does for us. Okay, you guys ready to try one? You guys can do this. This isn't new. We evaluated functions, right, several weeks ago. Yeah. So we can plug x plus h into a function. I saw y'all do it on a homework. I specifically had you do f of x plus h on a homework. And like f of x, well, you're just copying, right? So really, like, it gets a little messy there in the simplifying, but it's all stuff you guys have done. So try not to be intimidated because we're putting it all together into something big and kind of ugly, because this is all the pieces are things that you guys are totally capable of doing. I've seen you do them before. So here we go. Let's find f of x plus h minus f of x over h for, let's do like f of x equals 6 minus 5x. Again, write this in your first step, f of x plus h minus f of x over h equals, so f of x plus h is just your function with an input of x plus h, right? My function says 6 minus 5 times my input. And my input is x plus h. So all we're doing is replacing our input with x plus h. I don't know why I just changed colors for no apparent reason. And then f of x is just 6 minus 5x. Again, think of it in pieces. So now I can get rid of parentheses. Oh gosh, it's 10:51, I'm sorry. So you get -5. I think that almost everybody that I saw that finished got negative.